How's it going? So now it's time to talk about the ratio and the root tests. So basically what this is, we define a value rho as the quote between the next term and the previous term relative to this term as n goes to infinity. So this is useful to determine whether a sequence converges or diverges, because if the value of rho is between 0 and 1, the series converges. It has to be strictly less than 1. Could kind of be regarded as the common ratio in a geometric sequence, but it's kind of different because the common ratio changes for each term in these types of sums. Anyways, if rho is strictly larger than 1 or less than or equal to infinity, so basically exists and is larger than 1, then the limit of n goes to infinity of an becomes infinity, because each term will be larger than the previous term, and the sum will then diverge. If p is equal to no, we can't know jack shit because of the wonderful wonders of the universe. So let's do a fucking example here. This is the sum of n factorial divided by n squared times e to the nth. So basically what we do here is we do the ratio tests. I haven't built a fucking tower because I want to conserve space. So what this is equal to, this will sort of cancel out, and we will be left with n plus 1 here in this numerator. And the e to the n will just become divided by e, these two, and n plus 1 squared will be cancelled out with this term, 1 of the square, but I'll write it so you can see the step, n plus 1 squared, and we still have the n squared. So, and this is equal to 1 over e, the limit, I forgot to write the limit, as n goes to infinity of n squared divided by n plus 1, because this one cancels out with this one. So, and what do we know about this? As n goes to infinity, this will go to infinity. Definitely, so this diverges. Let's just say I put the die in diverges. Quick scoped. And we're back. So I figured I should do number 23 as well. It's pretty interesting. Here we got 2n factorial over n factorial cubed. So the ratio test in this case will become the next term as n goes to infinity, which then will be 2n plus 1, all this factorial divided by n plus 1, all this factorial. And instead of building a freaking tower, I'll just multiply it with a reciprocal of this, which is the same thing as dividing it by this, which will be n factorial cubed divided by 2n factorial. So, how can we possibly simplify this? Well, basically, if we think about it, I'll be a good boy and write the limit up for once. My pen is failing me. How dare you fail me, O faithful pen? Unfaithful bitch cunt pen. So the limit as n goes to infinity. 2n plus 2 factorial divided by n plus 1 factorial. Oh, all these freaking parentheses and shit. Let's keep it simple, homeboy. Jesus. N times n factorial cubed divided by 2n factorial. So, I'll be a good boy and write limit up again. It's fucking annoying though. So basically, if we think a bit, these terms are the same thing. We multiply each term, well, we take the factorial up to n in both cases. So these will cancel each other out until n. But the only difference is that we multiply this with 1 plus n. So basically, if we write this, we'll only get the last factor cubed, which is n plus 1 cubed. And sort of the same thing holds for these two, except that here this will cancel out, and these are the same thing, except you multiply this by the next term and the term after that. So what will that be? There will be 2n plus 1, the next term after this, times 2n plus 2. And if we look at this as n goes to infinity, what will this go to? Stupid motherfuckers. Well, it will go to 0. And what do we know if the ratio test goes to 0? Or if it's quite simply strictly less than 1? It freaking converges. So that's that.